Hello, good morning. Today, inshallah, we will continue on the mean value theory. We started this, I believe, last lecture. We talked about just a little bit about the definition of the mean value theory, and it's really very simple. Today, for this week work, we will try today, inshallah, in the coming two lectures to finish the mean value theory and its applications. By tomorrow, hopefully, we will be able to start on Taylor polynomials and how to approximate types of functions. It's really very interesting topic, and it's also connected to the MVT, the mean value theory. Okay, let's start with this problem. Another taste of how to use the mean value theory. He's saying, consider f of x which equal to ln of x defined on an interval a and b, where a is greater than 0 and less than b. Show that if a greater than 0 and less than b, then I can prove this issue, which is ln b over a and some possible. What's going to grab your eyes? The first thing that will grab my eyes is in the middle, he has a ln of b over a. The ln is related to the f of x, so I will start from here. And the b and a is related to our interval. Okay, this may remind me by the mean value theory, which states that at certain value, you will have the f dash of a function equal to the difference between the end points of the definition area or region divided by b minus a. I will start from this point. Let's write the MVT theory. The MVT, the mean value theory, states that for any function continuous and differentiable, I may find f dash c at certain point c, which equal to the f of b minus the function at a, which is the value of the function at the end points of your interval, divided by the distance for which the function is defined. Okay, now I have f of x, which is simply ln of x. In order to use this function with the mean value theory, from my point of view, I usually like to break it. How to break it? I will get each part by itself. I will get f of b, f of a. I will get the difference between b minus a. I will get f dash, then I will substitute with c. Let's start. So first thing, I will do f of b, which is simply gonna be ln b. Number two, I will try to get f at a, which is also simply gonna be ln a. All I have to do is just to make the substitution. Then I will prepare the denominator of this relation, which is simply f of b minus f of a, which is gonna be ln b minus ln a. And this relation moves some related properties of the logarithmic function. But I will leave it just right now. And also I have the denominator, which is b minus a. But as you see, I need the derivative of this function. So simply, I can have that f dash of x, which is gonna be the derivative of ln x. Do you remember? 1 over x. Perfect. So it's gonna be 1 over x. So just replacing at the value of c, I will have f dash c equal to 1 over c. So now I'm ready. This is done, that's done, and also this one's done. But I still remember some of the unforgettable probabilities about logarithmic function. There are 3 of them. No one can forget them, which is ln a plus ln over b equal ln a times b. And also ln a minus ln b, which is gonna be ln a over b. And same way, like if I have ln b minus ln a, it's gonna be a ln of a b over a. And if also I have ln a to the power of b, of course it's gonna be a b times ln a. I will need these properties. No one can ever forget these properties. Of course, ln e equal to 1. And also if I have x, I can put it in this form, e to the power of lemma of x. These are the most important properties of logarithmic function. I may need it. So now, once we wrote this, this is gonna grab our eyes because I can write it this way. Len of a b given a. I will start from this guy because this is the mean value theory. This is the application. I need to prove that len b over a and there is some inequality of some type. So I will start from here. Let's make a substitution. So simply, if I make a substitution, I have f dash of c, which is gonna be 1 over c. From the definition of this theory of the MVT, c is just only a scalar value in between the values of b and a. And from the definition that was given, that a is greater than 0 and a is less than b, so c is somewhere here between a and b. Now we are all set, so it's going to be 1 over c, which is going to equal to f of b minus f of a, which is len b over a, and this is divided by b minus a. Okay, let's get len b over a first on her own. So I can say that len b over a, which of course is a positive value. Are you sure it's a positive value? Why? Because b, yes, is greater than a, more than perfect. So it's gonna equal to a b minus a over c. This relation is very good. Now I will have to search for something to get this inequality. Need to search for something to get into this inequality shape. Okay, let me take this guy. If I took this guy, which means that c is less than b and b greater than a, I have double inequality, which matches almost what I have. Okay, let's get the reciprocal of this relation, which is gonna lead to that 1 over c is gonna be less than 1 over a and be greater than 1 over b. And this is one of the properties of the inequalities. And لما بعمل inequality, the relation will be reversed. So now, if I have c less than b and the greater than a, if you make the reciprocal, all the inequality signs will be to the other side. So it's going to be c less than 1 over a and greater than 1 over b. I've just thought to write it this way, it's going to be better. Okay? Are you with me? Okay. Okay. I need also to come more closer to this issue. Okay, let's try b minus a. I will multiply all this equation, all these brackets, times b minus a. If we did this, I will have b minus a over b, which is less than b minus a over c, which is less than b minus a over a. I can still remember this guy, which is related somehow to the logarithmetic of b over a. Now I'm sure we are on the right track, because simply we can replace this value by len of a b over a, which is less than, if we try to simplify this value, it's gonna be a b over a minus 1, and it's greater than b over b, which is 1 minus a over b. Let's see if it makes sense. Yes, it makes sense. Len b over a, this is a value greater than 1, so it's going to be a positive value. And this is also a positive value because b is greater than a, so it's going to be a positive. And same way like 1 minus a over b will be a value which is, of course, less than that. So now we have the relation exactly the same. The main idea that comes from proving such a pattern is the step-by-step trying to follow up with the ideas. I've started, first of all, how to connect or to get to this relation from the given, which is just only the function in between certain interval. And this interval, he gave me a condition for these scalar values, just to determine which one of them is greater than the other one. Then we started step by step from the mean value theory, then going through the results, then trying to change. Once we started with A, then C, then B, and we start to the other steps. Please, I would deeply recommend that you do it once more by your hand. Okay, let's.
الرول that we used عشان نجيب ln b over a equals b over a over c.
دي هنا ما دي مين فاليو ثيوري. هي دي. انا عندي معلومه جميله قوي. ايه نظريه القيمه المتوسطه؟ يعني مين فاليو ثيوري دي؟ يعني نظريه القيمه المتوسطه. ايه نظريه القيمه المتوسطه؟ بيقول لو انا عندي فانكشن بس تحت شرطين متصله كونتينوس وديفرنشال. ايه اللي انا هكسبه؟ ان لو مسكت الاف اوف اكس وجبت لها ديريفاتيف يبقى اف داش عند نقطه معينه ده الستوب. اي فانكشن اعمل لها ديريفاتيف يبقى انا جبت instantaneous rate of a change of this function at any point of its domain. يبقى لو الفانكشن بتاعتي عامله كده تخيلي ان في تانجنت بيتحرك على كل بوينت بيتغير مع كل بوينت. اوكي؟ ده اللي هو اسمه ايه؟ اف داش سي. ده اللي هو ده. طيب at certain point within the interval you will find f of b اللي هو ال value of function at the end point minus the value of the function at the beginning divided by difference بيساوي ال change او الريت اوف change المتصل. فاهم قصدي ايه؟ اوكي ده اللي انا عملته من البدايه معايا برنسس دي. يبقى انا بدات على طول الفانكشنز ديفايند. يبقى انا رحت جايب الفاليو بتاعت الاف عند البي والفاليو بتاعت الاف عند الاي. بعدين عملت divided by b minus a. f dash c it will go forward because f of x then x f dash 1 over x so I can find 1%. يبقى الستيتمنت اللي بيتقال هنا ان انا اقدر الاقي value of c بين ال a وال b to prove this relation. يخلي الكلام ده صح.
هو ده والبي روت لفوق.
دي ايه؟
يعني ln b over a احنا كده بنريرايت
اللي فوق ده فين؟ ده يعني؟
يعني عملنا
معلش انا اسف بس خدت اكسترا ستيب. انا كل اللي حصل انا عملت مالتيبليكيشن للبي ماينس اي اون ذا اذر سايد. معلش انا سبقت بس وانا بتكلم. فخليت بي ماينس اي اوفر سي ايكوال ذن بي اوفر اي. عشان الريليشن دي انا برضو حليت المساله فعارف ان انا هحتاج الريليشن دي. لكن طبعا انا هاف رايت هيد. اول ما هاجي هنا شايفه ده 1 اوفر سي انا اقدر اعمله هنا. 1 over c اللي هو ده بيساوي ln b over a b over a divided by b minus a. I can make this replacement then. بعدين to multiply the whole equation by b minus a. يبقى انا جاهز على طول اشيل واعمل substitution. Do you understand what I'm saying؟ او كنت اقدر على هشيلها واعملها بنفس الاسلوب. ف it's doable. انا اسف انا اللي مست. عموما انا هعيدها من تاني. تاني كمان مره. ادي الثيوري اللي انا بكلمك عليها ان there exists C which belongs to an A with B, the open interval, which means it's between them. F dash C will equal to f of B minus f of A divided by B minus A. Okay, we will use the mean value theory. يبقى f of x is differentiable and continuous on this interval. لأن الانترفال اللي أنا عامل بيها A is greater than 0 and less than B and it's all in the positive side. The arithmetic function domain runs for R positive. Okay? So, next step, f dash c equal ln b minus ln a over b minus a. Then, once more, f dash c is going to equal to 1 over x, and I will make the substitution, so it's going to be 1 over c. And you have then b minus a, which is then b over a. From this point, I can multiply both sides in b minus a, so I will have b minus a over c equal ln b over a, or just wait for the inequality. Okay, I made it. Similarly, like, since C is greater than A and less than B, if you get the reciprocal for this inequality, you will have 1 over C less than 1 over A greater than 1 over B. So it's going to be like this. Okay, this is why I thought it is better to rewrite it on the other side. It makes you more comfortable. Multiplying by b minus a, the whole issue, then I will have this guy, which is b minus a over c. Now I can substitute from ln b over a, start to get the shape that I want, and the probability is proved. Okay, done. تمام؟ حلو. تعالوا بقى نبص على let's look at rules theory. Rule theory, it's a special case from the mean value theory. Rules theory states that if you have another condition, let's remember, what are the conditions of the mean value theory? Continuous and differential. For rules, you have continuous differentiability, and the value of the function at the beginning of the interval is equal to the value of the function at the end of the interval. So f of a equal f of a. If you have something like this, so you are actually in between a function to do this, you will be between something like this or something like that. Am I right? Then it's an introduction, as I told you offline, to the crown. Either a maximum or a minimum. Okay, so this is what it starts. It says, so let f b belongs to a and b, be a function that satisfies its continuous differentiable. The value of the function at the beginning and at the end of the interval is equal to each other. We can find a value of c for which the slope of the tangent at this point equal to 0. And of course, the maximum or minimum. Maximum or minimum. Okay, so this is rule theory and how it is stated. The mean value theory, okay, or the difference between the mean value theory and rule theory. The difference, of course, this one is a special case from the mean value. The mean value states that at some value of c, you will find that the instantaneous rate of change will equal to the rate of change between the end and the beginning points. But for rules theory, it states that you will have a horizontal tangent, and this is how it is explained that rules is a special case from the mean value theory. These are the three consequences of rules and the mean value theory. First of all, if you have f dash x equal to 0, and that's wrong for every x belongs to the interval of f, f is a constant function on R, which means the function f of x is just only a constant. Which makes sense. F of x, if it was a constant function, once you try to get the first derivative, it's going to equal to 0. Okay, if f and g are two differential functions in I, and f dash x equal to g dash x, their derivative is equal to each other, and this is run for every x belongs to I, then f minus g is going to be a constant function also. Okay, for any x belongs to I, and this is the most important one, this will determine the period that you have strictly increasing function or strictly decreasing function. Okay. نحاول ده شوية.
هو constant function
يعني value equal like 4, 5, 6, some number. Okay? It's not a function in x. Okay? طيب لو أنا بصيت على number 3 بيقول if for any x belongs to unit interval, f dash x is greater than 0, then f is a strictly increasing function. Now I can find the monotonicity of the function, finding which part of U domain the function is going to be increasing, and for which part the function is going to be decreasing, and vice versa. To see this in action, let's solve this problem. Now, you will study the monotonicity of this function. Let's see about this function, periods of increasing and decreasing. It's really very simple. All I have to do first is to use rules theory, which is gonna develop the points or the vertical points. This is really, very simple. So, the first step, I will start with the following. F of x, and this is just only a function in one variable, so f of x equal to x squared times e to the power of x. So I will start with getting f dash x. So f dash x, it's gonna equal to. Those are two functions multiplied in each other. So once we start the derivative, we start getting the derivative of the first function by the second, and then vice versa. So it's gonna be differentiating x squared, which is gonna be a 2 of x times e to the power of x plus the first part, which is gonna be x squared times e to the power of x. This is for the first step. F of x is gonna be 2x times e power x, then x squared, and differentiation of e power x is gonna be e to the power of x. Of course, you remember the differentiation of the exponential functions. Once we have exponential functions, its derivative is gonna be the exponential function by itself times the derivative of its power. Do you remember? Okay, now I can simplify stuff. So I can simplify this expression by simply taking x dot e to the power of x as a common from the whole expression. So from the first part, you will have just only 2 at the remainder. And from the second one, you will have just only x. So multiplying once more, I will gain the same expression. So this is for f dash of x. Rolle's theory states that the derivative will be equal to 0 at some points within the domain of this function. So all I have to do now is to put f dash of x equal to 0 in order to search for the points at which the rate of change equal to 0, which means it is the crown, either maximum or minimum, as we will know down the road. So once we do this, we will have an equation now which contains e to the power of x, which is an exponential function, times x2 plus x equal to 0. Once you try to solve this equation, you will find the following. First of all, for this part, or for this term, e power x never equal to 0. It will equal to 0 once x tends to negative infinity. So this guy will never equal to 0. This means that you will have to solve simply this equation, which is x2 plus x equal to 0, and this is simply will lead to two facts, either x equal to 0 or x equal to a negative over 2. So now you have two critical points. Are you with me, Dina? Any questions? e power x ممكن تساوي 0. فكر كده. For any value of x. هل ممكن تساوي 0؟ No way. لو انت عندك شك، اوكي، افتكري الجراف بتاع الاي اوف اكس. ده كده y. Do you remember؟ ده كده x axis. e to the power of x. It's yes, exactly right. More than right. This is the shape of y equal to e power x. And this will happen at 1. Is there any value in the x-axis for which the value of y equal to 0? You don't have it. Okay? Yeah, بس في جزء مش بيساوي 0. ما انا عندي x سكوير بلس 1. لو الايكويشن دي فيها x سكوير بلس 1، هل x سكوير بلس 1 ممكن يبقى بزيرو؟ لا. لأن x سكوير لا يمكن يساوي نيجاتيف 1، صح ولا ايه؟ يبقى إذا أنا هنا لما باجي أحل الايكويشن دي لقيت إن الجزء الأولاني ده will never equal to 0، مش هيجيلي كريتيكال بوينتس. لكن مين اللي ممكن تو هيت زيروز؟ دول. ده امتى تو هيت زيرو؟ لو الاكس بتساوي كام؟ 0. والجزء اللي جنبه ده امتى تو هيت زيرو؟ لو الاكس بتساوي كام؟ نيجاتيف 2. يبقى you have how many critical points? Just only 2. Okay, I will go to the x-axis. This is the x-axis from negative infinity and it runs to positive infinity. The two critical points are negative 2 and a 0. At these 2 points, the slope of this function or the slope of the tangent of this function at these 2 points will be a horizontal line. So now I will study the domain from negative infinity up to negative 2 to see if the function is increasing or decreasing in this period. Then I will check for this part which is runs from negative 2 up to 0. And then simply like from 0 up to positive infinity. تمام يا جميل؟ Okay, for the first interval, from negative infinity up to negative 2. Let's use f dash of x. This is f dash of x. So f dash of x, which equal to e to the power of x times 2 plus over x. If this guy is less than 0, you will have decreasing relationship within this interval. If this guy is greater than 0, you will have increasing relationship within this point. Let's start. If I start to choose any number, which is between negative infinity and the negative 2, I believe negative 3 is tempting. Okay, let's start. If I put negative 3 here, it's going to be positive value. Am I right? صح يا إيه؟ هيبقى e power negative 3 positive. بعدين هنا negative value وهنا negative value. Negative times negative يديلك. يبقى f dash of any c belongs to the interval from negative infinity to negative 2 will be greater than 0. So through this period, it is strictly increasing function. So the function within this part will be increasing. Even in this part, the function will be increasing. Okay, same way like, I will take now any number belongs to the interval between negative 2 and 0, which negative 1 looks tempting. Let's do it once more. So between the negative of 2 and 0, negative 2 and 0, same way like, f dash of x will equal to e to the power of x times 2 plus over x. Let's start substituting. خلينا نعمل substitution. If I use the negative 1, so this guy is positive. This is going to be negative, but that's going to be a positive. Positive times negative will be negative value. صح؟ يبقى إذا ده معناه إن الانترفال دي هيبقى الفانكشن بتاعتك مالها decreasing. Same way like if I choose number within the last interval, which is from 0 up to infinity. What you like to use? 1, positive 1 for example? Okay, if I try to use positive 1, so it's going to be positive, positive, and positive. So the result will be increasing as it is. If this is increasing, then decreasing, okay, for this part. So this will happen once you have a crown like this, yes? And for this guy, it has been, this part is increasing, is decreasing, and then here it is increasing once more. So this is going to be, I'm sorry. So this is how it's going to be. So that's a maximum and that's a minimum. Down the road we will go through that. طبعا نفس الستبس تاني اهو. Let's get into critical points. First get the first derivative and put it equal to 0. Let's determine the intervals. So I will have 2x e power x squared e to the power of x, taking x as a common, then x as a common. This will leave me with this equation, 2x plus x squared equal to 0, which means this will happen at x equal to 0 or at x equal to negative 2. I can now, using the theory that we wrote previously, that for x belongs to I, f dash x greater than 0, then f is strictly increasing, and vice versa if the value of the first derivative is less than 0. So starting from this side, which is from negative 2 up to negative infinity, I would choose any number. If you choose like here, for example, negative 3 or so, and you make the substitution, this guy is going to be negative, this is going to be negative, so multiplying them together is going to be positive. Positive times positive, so it means an increasing. So I will have a maximum point at this time, increasing, then decreasing, and so on for the other intervals. Okay? أي أسئلة؟ كله تمام؟ Are you sure? 100? Okay, very good. Let's go for real valued functions of several variables and let's describe how we can do the mean value theory. Princess Dina, do you remember the mean value theory? Can you see it? Close your eyes and see. Huh? F dash C equal f of b minus f of a divided by b minus a. That's it. Okay? Let's see the case once we start to talk about functions of several variables. Now I have f which such that d is a subset from Rn into R, which is a differentiable function on d, and it's an open and convex domain for this function. So there exists C, there is some value of C, which belongs to A and B interval or whatever. لأن ممكن تبقى region أو ممكن تبقى interval, depend on the number of variables. And such that f of b minus f of a, instead of having f dash, we have the general definition of the first derivative, which is the gradient. And this is why we took it in the first two lectures, how to find the derivative, how to find the partial derivatives. Then we went through the gradients, do you remember? And we also passed by the Jacobians. So all of this an introduction to be able to use this method and what's coming later. Okay? So this is the gradient. Of course, this is exactly like the form that we wrote just a few seconds ago. This is f of b minus f of a divided by b minus a, which is equal to f dash c. But we multiply both sides in b minus a. So it will be like this. The new thing is c can be expressed as a function in theta, as a relation between a and b. I will need this relation, okay? Because sometimes I'm not going to be talking about just only an interval with one variable, but with multiple variables. So maybe this value will make your life easier, as we will see. So for some c, which belongs to a and b, I can find that f of b minus f of a equal to the gradient at this point, which is c, times b minus a, where c is equal to, the interval runs from a to b. A is smaller than b, am I right? Okay, so how to memorize the value of c and theta? C will equal to 1 minus theta, this is what I want you to remember. Then times A, which is the beginning of the interval, plus theta times B. So this is what needs your focus. How to express C once more as a function in theta. So C will equal to 1 minus theta times the beginning, then plus theta times B. Okay? This is really, really important. And the theta is a value between 0 and 1 to ensure that theta belongs to the interval which is b minus a. And this has a proof, and you will find it, this is the proof, it's already in the main notes. I don't have to go through it, as you can see. It's really from the definition of the derivative step by step, and you will get the result that theta must be greater than 0 and less than 1. So this is the proof of why theta is between 0 and 1. Now, we don't have to do it for the time being. If you need to go through, just review the main slides. But I will need to go for something like this. Okay, he is telling me consider f such that the domain belongs to R square into R. Sorry, I'm mapping stuff from R2 into R. Okay, so for R2, I will map them into just only R. The function will run like this, e to the power of x plus y squared. And the points are a and b. See, now we start to talk about points in more than one dimension. We are talking in R2. So it's -2 and 0, and the b, which is 1 and 1. Find c, find some value of c, which is this main search of a value at which the instantaneous rate of a change will equal to the rate of a change between the beginning and the end of this point. Okay, or a point belongs, what means C belongs to A and B, if A and B 2 points, so it can connect a segment to a straight line. So C, it's going to be within the middle of this segment. This is what's all about, that you will see about finding the value of C belongs to a segment between A and B. Are you with me, Dina? Okay, so find C belongs to A and B such that f of B minus f of A equal the gradient at f of C times B and minus A. Observe that the numerical solution of this equation is theta equal to 2.56. This is some additional information it was given to you. You may need it, okay? So, bottom line, I will start once more from the beginning. First of all, let's write the MVT, the mean value theory, which states f of B, once more, f of B minus f of A will equal to the gradient of f at some C, some, times B minus A. This is the mean value theory. I will start step by step. First of all, I will try to get the value of f at B, which is really a piece of cake. Since A is -1 and 0, and the B, which is 1 and 1. Are you with me, Ms. Dina? So I will start with f of B. So the function that we are talking about is an f of x and y, which equal to e to the power of x plus a y squared. So, okay, let's start. Getting f of b. So, f of b, it means the function value at the point 1 and 1, which is gonna result to e to the power of 1 plus 1 to the power square, which is gonna be 1. Are you with me? All makes sense. Same way like I will start going for f of a. So now I will get the value of this function at the second point. What's the second point, please? -1 and 0. So I will start making this substitution in this function. So it's going to be e to the power of -1 plus a 0 to the power of 2. So it's a 0 to the power of 2, which is 0. Okay? So now from these two values, I can get now f of b minus an f of a. Am I right? So making this difference, so it's going to be e plus 1 minus e to the power of -1. All perfect. So the right hand side, the left hand side is already, I have it. Now I will go for